Okay, right now we have the circuit only running on our battery power, and that is when the main circuit's on, it'll be running through this buck converter. The other ones will be running on the other buck converter, the sensors. Here's our humidity, ambient, and 3 IR sensors. If we go over to the code, we can see that it's only running on the battery.
So right now, we're not connected to the device, so we can't see any code, but we can log into our website to see what is going on. We enter our credentials here, and we'll see our panel select. We'll pick panel 1, and we can see that it's active, but it's running on the battery backup. So here we have our humidity, ambient temperature, our panel status, and the phase temperatures. So now all device sensors that get sent in will go to the database, and we'll show you that now. And Jamie will explain what you see there.
So if you look at the most recent entry, you could note the ID number and the corresponding timestamp. So that was the most recent entry. So now upon rebooting here, reloading, you'll see that it's updated with a new one, a new ID number, auto-incremented, and then the latest timestamp.
So now we'll go back to the circuit, and we're going to show Devin connecting it to the main power and flicking the relay that will run the whole device.
Yeah, so now I'm going to turn the main power on and get the new relay to latch. So now we can see that the battery is turned off, and now it's running on the main power supply, and the sensors will be running.
So now Devin's going to implement some heat going through the phases, and he'll be heating up these phases with the heat gun. If we come back to my web page here, when we get a new request, we'll notice that the status here on the backup battery will change, and we'll notice that when he's heating these up, our phase temperatures will change, and we'll get a difference in the phase temperature. With high values and so on, we'll get alerts. So if we scroll back up here, we can see that it is now active and running on the main power supply. So that status kind of shows the condition of the device. We also have the new latest update time on the code, showing when the last report was entered. Now with Devin, we're going to come down here and observe, and we've noticed that the temperature on phase 3 has increased detrimentally. So this is high risk, as you can see by the legend, because it's changed by 34 degrees in a very quick period of time. Here we can see what the temperature change was. It went from 24.7 degrees to 58.54 degrees. As this changed, if you want a better idea of when these happens, you can click the log, and you'll see that the time between these happened. So one was at 22:27:47, and exactly 40 seconds or 33 seconds later, we got this change. So it sent the alert right away. If we go back to our panel, we'll notice that these changes are happening as Devin keeps heating up the different phases. Phase 2 has a moderate risk because it had a quick change of 23 degrees, and phase 3 is cooling down, so you can tell it was a quick flash. Here we have our temperatures here, and if Devin heats up the temperature phase beyond 70 degrees, we'll get a warning, and right here, warning, high temperature on phase 1. Check the logs. We'll notice that phase 1 down here has 55 degree change, and we read a temperature of 80 degrees, bolded in red so you can exactly see where what's wrong.